Welcome back to another coding session. We're back into Bangalang, our low-level explicit procedural language, which is destined to run on the CPU and the GPU. Currently only running on the CPU and also currently only doing very basic things. But in our last episode, we got stuck into some procedure calls. You can see some examples here. We're calling +1 and add and exit. But currently, if we go to generation, we can see that these are all, like this is where we're generating our assembly. We have this at the start, and then we generate all of our statements in our program. And then at the end, we have these procedures which are just hard-coded assembly. So we haven't been able to define our own procedures yet. And that's what we want to do now. So let's start from the beginning. Of course, I have to open this grammar file twice so that it actually works. Here's our grammar for our language. And what we want to do is we want to add a procedure definition. So we want to be able to do something like, we've got +1, so let's just, as a simple, hopefully a simple example, let's do +2. And we'll say, this is our in, or our num, let's call it a number, num, and then we're going to return num +2. So that's us defining a procedure. It's the same kind of declaration syntax as before, like this is declaring a number. But here we're saying it's procedure with these arguments, and here's the body of the procedure. Before we go any further, actually, there was something that I figured out and I would like to show you. I'm using CLion, so I'm using a JetBrains IDE, and I kind of wanted some syntax highlighting. We don't have syntax highlighting because it's not a known language, you know, Bangalang, we're just making it up. But I can go in here and make a new file type, Bangalang, and add support for paired brackets and braces and parentheses. And then I can add our keywords. What have we got? For, if, for, else, if, proc, and return. So proc and return are new keywords that I'm just adding now. So these are all our keywords, and I can say OK and apply. And then I need to add a file name pattern, so I can go star.bang. So if anyone else is following along and creating a language also using a JetBrains IDE, you can do this. And now we have a little bit of syntax highlighting. Just basic, you know, the numbers have a certain color and our keywords have a certain color. So it looks a bit nicer, a little bit nicer. Yeah, so this is our new syntax here. So we have these two new keywords, proc and return. Well, let's not get too far ahead of ourselves. We've defined this, or we've said this is what we want it to look like, but we haven't actually defined it yet. So let's go to our grammar and define all of this. I think it's very similar to a declaration. And you could potentially extend this declaration syntax to say, like, this could be an expression or it could be a procedure declaration. But when it comes time to generation, I think it's going to be easier if it's just a totally separate thing. Maybe down the line we'll combine them, but at the moment I'm just going to keep it separate because I think it'll be simpler. So we're going to have identifier colon equals, and we have a couple more tokens here. We have proc and opening bracket. And then afterwards we have a closing bracket and a scope. Right? Identifier colon equals procedure, and then in brackets we'll need to change this, but in brackets we have our parameters and then a scope. So the parameters is going to look something like what we have down here. So this is the call, where we call a procedure. And it has this funky stuff in here, which is just saying you can optionally have an expression, and then optionally you can follow that expression with more expressions, and they're all comma separated. There might be a better way of expressing that using the syntax, but that's the best I figured out so far. So maybe we can copy that up here, because we want the same kind of idea. Or this time, the difference is that we're dealing with identifiers, right? Because here we're saying like it's an identifier. We could have num2 as well, so we've got two identifiers for our input variables, our parameters. So that's our procedure, and I want the procedure only to be up here as part of the program. I don't want it to be within a scope, so we can't have procedures nested in scopes or nested in other procedures or anything like that. I feel like that's something we could do down the line if we were to introduce like lambdas and things like that. But right now, yeah, simple is the name of the game. I probably am going to mention this many times, but I'm just trying to keep things simple. So we want a bracket there and a slash there. So we want a procedure or statement up here now. So a program is one or more procedures or statements. Okay, so now we have a procedure production, and then we also have a place where it can appear in the program. And there's one other thing that we need, because this one line that we put in here is a new kind of statement, a return statement. And actually what I'm also going to do is I'm going to put it up here. And I'm going to say we're returning this expression, because, well, otherwise I have to do some special stuff where like return can only appear in here, but not out here. And I don't really want to do that because that'll complicate the grammar a bit more. So I'm just going to make it so you can do it everywhere. They definitely have different meanings here. Like this one, I replaced the exit procedure call with return, and it's going to do basically the same thing. It's going to cause the program to exit, and this is going to be the exit code if we put it in the body of the program. But if we put it in a procedure, then this return is now going to say, it's like this. It's going to return it to the caller. Okay, so we need a return statement. I'll put it after assignment. And it's a fairly simple statement, I think. It's the return keyword, yeah, followed by an expression. I think that's it. And that needs to appear somewhere. So I'm going to put it in here as a type of statement. And that's it. Okay, so I think that's how grammar sorted. We have two new keywords, or two new tokens, which I believe are keywords, proc and return. Seems to be our answer to everything right now. If in doubt, make a new keyword. Proc return, like so. That's all we have to do in our tokenizer. And now in our parser, let's start with parsing a procedure. So that will go here. I try to order these functions in the same order that these are ordered in the grammar. parse, what is it? Procedure. Parse procedure. And I guess it's going to be a lot like a declaration, isn't it? So where's a declaration? Here we go. Declaration. Let's go back up here. Only it's a procedure. We'll make a procedure node. So we're going to need a type for that. Procedure. Then, yes, we have a left-hand side token. I'm starting to feel like we have this code here duplicated in way too many places. And I've been putting it off for a long time, but I think now is the time to put it in its own function. So let's have parse identifier. Create a parse identifier, which I guess will have the same signature as this. Yeah, so we get the token, the node, I guess we're just assigning. So it's a very simple function. And then I guess we need to return. Because we have the named return, so we can just assign to that. Yeah, very simple. I mean, it's really simple code, but it's just, you know, I think it's been duplicated in too many places. So now I'm going to search for this to see where it is we can use it. I think our name node can be parse identifier. Let's go to the next one. So left-hand side node, like so. This is also left-hand side node. And then this is our new code, isn't it? Which is also left-hand side node. Fantastic. Now we don't have that duplicate code everywhere. So a procedure is an identifier followed by a colon equals, and then what are we talking about here? A keyword with the value proc. Then we have an opening bracket, and at the end a closing bracket. And what we have in the middle is a bunch more identifiers. And I think we have the pattern kind of established when we parse a call. It's very similar. We have this kind of thing going on. So now, as long as we don't find a closing bracket, we will parse an identifier, which is our parameter, and add that. And if we still don't have a closing bracket, then we must have a comma, because they're comma separated. And then we wrap around. So actually, according to this syntax, you could have a comma at the end. Like this would be valid syntax, which I kind of don't like, actually. But I can't be bothered fixing it. So we'll just do a good old to-do. Allows comma at end of params. And I think we need to put this down here as well, where we stole this code from, because it suffers from the same problem. But that's all right. So I think that's, no. That's most of the parsing done. There is one more node. After the closing bracket, we need to parse our scope. the body of the procedure. Cool. So that's parsing a procedure. And we need to call that up here. So basically, we're going to detect if we've found a procedure. If so, we'll parse a procedure. Otherwise, we'll parse a statement. We're going to do that in the same way that we did, yes, here. Even though we identified that this is not a good way to do it, this is what we're going to do for now. We're just going to manually check that it has the right combination of tokens. So we're talking about colon equals, and then I'll just say value equals proc. This is all a bit hacky. Really, ideally, we need these to return not only a node, but also a Boolean or something to say whether they were successful. We can do that in Odin. We can say like this. This is how we do multiple return values. And that's quite a common pattern, it seems like, in Odin, to have the last returned variable be like a Boolean or some sort of error code, or something to say what went wrong if something went wrong. That way we could just, here, what we would do is just try to parse a procedure, and if that failed, then we would fall back on parsing a statement. And that way, as this procedure, maybe the syntax for a procedure changes, and this code still works. Whereas right now, if a syntax, like if it wasn't colon equals, if we changed it to colon colon, we would need to do this. Otherwise, this code would be broken, essentially. Anyway, good enough for now. So that's our procedure. I believe that's the only place, that's the only place that we needed to add it. So that's parsing the procedure. Now we need to parse our return, which is a statement. So if we're in statement and we look at the first token and it's a keyword, we already have this here. We find the keyword return, then we parse a return. Nice, nice, very easy. And we'll put it after this parse assignment. Parse return. I think this is also a new node type, is it not? Yes. So we'll put that after assignment. And we'll come back. Now we have a return node, and a return statement is just return expression. So all we want to do is verify that this first token is the keyword return. I don't want to call that right-hand side. And then we have an expression to parse. That's it. I think that's it. I think that's parsing done. Parsing is, I like where we've gotten to with parsing. I feel like it's, I mean, expressions were something complex for sure, but just typical statements and things are usually quite easy to do. It's nice. Okay, now generation is always where things get a bit more tricky. So let's generate a procedure. Here's generate statement. Generate procedure. Well, let's go to generate call maybe. I think some of this we want to steal. let's copy this. I don't think we actually want all of it, but some of it's useful. Definitely this, we have a name node. We don't need to verify this stuff. So when we're calling a procedure, we push stuff onto the stack. And when we create a procedure, the equivalent that we need to do is, because down here at the bottom, or somewhere down near the bottom, what we're going to do is generate a scope, right? And into that scope, we are going to need to pass a context, right? And that context is going to tell us what, along with some other things, it's going to tell us what variables we have access to. So when we call a procedure, we're putting some variables on the stack. And now when we generate the scope for the procedure, we then need to inform the scope that those variables exist. Okay, and the way we do that is going to be similar to what we do with scopes. So let's go to scope. Yeah, here's our scope code. We have this code here, which is copying a context. And I want to extract that out into its own function. Copy gen context. Whoa, I better say CTX. And that's a gen context. We're also returning a gen context. So let's rename that to CTX copy. Whoa, no. Rename this to CTX copy. Okay. And we're returning CTX copy. So then, where is our scope? Here's our scope. So this is what we copied. So let's instead put this in here. Yep. And we need to dereference this because we're not passing a pointer in. And also it's an assignment. Okay. Cool. Now when we go up to our new code, we also want to do that. Create a scope context. But we don't want to copy these vars across. Okay, so what we've used scopes for so far have all been inline things. They've been for for loops, if else, or even just a plain old scope. So they're all inline, which means that they have access to the variables outside of the scope. When you go into the function, that's not a case. That's not the case. Like if we have something like this, foo is 0, and then we just do +2 num. So this is a pointless variable, but I do it because what I'm trying to say here is that if we do +2, if we call this, and then we call this within, this function should not have access to foo, right? That doesn't make sense. But this parent gen context that comes in is going to have foo. Sorry, up here in our procedure. This is going to have foo. So we want to make a copy, but we don't want any of the existing variables. So actually, I might make the default false. So down here in the scope, I'm going to say true. So we'll say like a copy stack vars. Like that. This is kind of nice. I can just do a regular assignment, a regular declaration syntax. This is actually what I was thinking for my language. Like at the moment, we're just saying they're identifiers. But essentially, in the end, I would like these to become declarations. So that allows you to provide default values. Also, you know, like we can do this to explicitly say that it's a bool, or you could take this away. You know, it's all the same syntax. It's just a declaration of a variable that comes into the procedure. It is a declaration, really. Anyway, enough of that. So now this stack vars. So if we want to copy the stack vars, then we do this. Okay, so we've got stack top if stack vars, stack top if for index, we have not been copying. I guess it hasn't bitten us in the ass yet because we have not had any nested fors. But that should also come across. Actually, you know what? When you go into a procedure, those indexes do not need to come across. They could, it wouldn't hurt, but it's also not necessary. So you know what? I'm going to say inline. So if this scope is inline, like all the uses we've done so far, then we copy all this stuff across. Yeah, I'll space them out the same way that they are in the struct. All this stuff comes across. Otherwise, it doesn't need to. There's not much need for it. So here, pretty much all we have is the stack top. That's the only thing we're copying across. And then here, we want to say child index +1. So we're going to loop through all of the children except for the last one, because the last one is our scope node down here. We can do this. The last one is our scope node. Why is it not? Oh, that probably needs to be an address. Yep. So what this is saying is basically loop through all of our parameter nodes that are the children of the procedure node. Remember, first it has, the first node is the name of the procedure. Then it has parameter nodes, which are just the names of the parameters. And then it has the scope node. So we're looping through until we'll keep looping through all of them except for the last one. Get the param node, generate an expression. No, we don't generate an expression here. Yeah, when we call the function, we generate an expression and push it onto the stack. So here we just want to tell this context that something has been pushed onto the stack. So we want to put it into stack vars. Param node dot value equals stack top. And essentially we want to mimic what we do during a declaration. Where is a declaration? somewhere down here. There it is. During a declaration, we do this. So this is kind of all of it together, you know, these first two lines of what we do during the procedure call, but this is what we need to do to the context. Actually, let's copy that and bring it in here. In this case, we're talking about the parameter node, and we're using the scope context. So it advances the top of the stack and stores the location in the stack location of the variable. So then when we go into this scope, that scope now knows about these parameters. Cool. We don't want to do the call here. Oh, we don't have a space there. I am a stickler for these things, if you haven't noticed yet. This is the call. Should be like that. These are comments, right? Yeah, I always have a space before my comments. So are we back at the procedure now? Yep, generate procedure. So this here becomes the label. %s colon. Yeah, that's it. So it's just the name of the procedure with a colon. That's the first thing we do. Then we find the parameter count. Do we care about that? Is there anything else we need to do? We've set up the parameters. I think we just generate our scope. Hey, I don't think we need to do any of this sort of stuff. We just generate our scope. I think that's it. Let's see. We'll generate some assembly and then we'll find out whether it's wrong or not. And these procedures we want to generate. So what I'm going to do is I'm going to generate them down the bottom. Remember with these hard-coded ones, we put them after the default exit. So the code isn't, like these statements are never going to flow through to these procedure calls because they have to pass the exit. So that's why I put them at the end. So I'm just going to say if node.type does not equal procedure, then we generate a statement here. And then in this loop, we're looping through the same nodes. We're going to say if it is a procedure, generate the procedure. Yeah, I think that looks nice. So I think that's. So I think that we've generated this, and we've also generated it within the program. So I think that's procedure done. Now we need to generate our return. So we're going to go down to down past assignment. Let's copy this assignment code. I'm going to do generate return. So this is a return. We only have one node, right? We only have an expression node. So we don't care about any of this, but we will generate an expression. Okay. The question is, what do we do with that expression, the result of that expression? And remember back here I said that these two returns are going to be handled quite differently because this one's in a procedure, this one's not. And the simple way that I'm going to figure that out, maybe there's a way to do it without doing this, but I think this is fine. We're just going to have a Boolean to say whether we're in a procedure or not. Very simple. So when we copy our context, we need to copy that also. And not in our return. So when we do a call, when we do a procedure call, is it when we do a procedure call? No, I think it's when we generate the procedure. Yeah, because we create this context. This is the context that's going into this scope. And if we have a return statement inside the procedure, the return statement will be inside this scope. So what we need to do is say in proc equals true here. Cool. So now we know whether we're in a procedure or not. I think we can scroll up a bit here to find the exit. This is the code for exit, which is what we need to do when we return, or it's one of the things we need to do. So we say if ctx dot, if we're in a procedure, we do one thing, otherwise we do an exit. We don't need to have a return here because, or actually, that's what goes here, right? If we're in a procedure, return. If we're not, we do an exit. And we're going to use R8 here because the result of our expression is going to be an R8. And in this case, because our convention is that the return value will be stored in R8, generating expression puts the result already in R8, so there's nothing more we need to do. This is already ready to return. So I think this is our return. I think this is how we generate a return. So we need to call that somewhere. And that's in our generate statement, right? If we're looking at a return, then we generate a return. I feel like I've gone through all the steps. Kind of. I also feel like I have not done everything. Failed to generate call undeclared identifier +2 at line 77. So that's when we're within this function. We don't know what +2 is. Interesting. Well, to be fair, +2 we have not defined yet, have we? Because when we do a call, we check to see that it's a known procedure. So I think this is, yeah, it's failed to generate call. So it's because the procedure is not defined, right? These are the only procedures we defined, our hard-coded ones. So I think what I'm going to do is go built. These are our built-in procedures. And I'm going to add a dynamic array of procedures to our context, which we then need to fill out, right? When we're generating our program. And we can't do it as part of this because this is happening right at the end. So when we if we did it down the bottom, then when we generate these statements, the context doesn't know about those procedures yet, right? So what we have to do, I think, is, well, I mean, the easiest thing to do, I think, is just to say, if we come across a procedure, just append the procedure. Oh, not a $, ampersand. Maybe just append the procedure. So that would be node.value. Wait. No. It's the first child of the procedure is the name. And then the length of the children minus 2 is the number of parameters. Because remember, our procedure object has a name and a parameter count. And our procedure node has a node for every parameter and a parameter for the procedure name. And a node for the procedure name. And then also it has a node for the scope. So we subtract those two. It doesn't look happy, so maybe I have to go like this. Dot value. Okay, cool. So now we've added all the procedures to the context. We have an error here, which is good, because we need to duplicate this loop. First, we'll check for a built-in procedure. And then we'll check the context procedures. This is a bit of a waste here. We probably shouldn't enter this loop if we've already found it here. But, I mean, it's not such a big deal. I think it's fine. So if we run that, still undeclared identifier. Okay. So let's have a look. This context is the Odin context. CTX is ours. Procedures is empty. Procedures is empty. Do we ever go in here? Wait a minute. Wait a minute. When we copy our context, we also need to copy our procedures now. Yeah. Yeah. Is that it? Yeah. Cool. Let's have a look at some assembly. Let's skip to the bottom where the interesting stuff is. So these are our new procedures. We've gone right to the bottom past X. Like, these are our hard-coded procedures here. That's these ones. And now this is our new procedures. So let's see if these look right. So when we do +2, the whole thing is just a return statement. So we take RSP +0. I don't think that's right, because if we come across here, we see that when we call, we push the instruction pointer to the top of the stack. This is pointing at the top of the stack, so this is going to be the instruction pointer, where actually that should be one of the parameters. So when we do our, when we generate our procedure, we copy all the new variables in, then I think we need to do this again. Yeah, so these ones are accounting for our parameters, and this one is going to account for the instruction pointer. Yeah, so now we have +8. I think that's correct. So we put our parameter into R10, we put 2 into R11. That's doing this function here, right? we're doing this addition. Then we do the addition, which puts the result in R8, and then we return. And R8 is our return register. So that's perfect, I think. Do plus 2. We're declaring R8. So we put 0 into R8 and we push R8. That's us making this pointless variable. Then we have a return, so we're getting, this is the parameter. It's plus 16 now because we have this extra variable on the stack. So our parameter is plus 16 in this context. Then we push that onto the stack. Oh yeah, because we're doing another procedure call. So we push it onto the stack because it's the parameter to this procedure. We call that procedure. Then after the procedure call, we clean up. So this is clearing this. It's the reverse of this, basically. It's undoing that. Then we move the result of the procedure call into R8, which is a no-op. It's pointless, but whatever. And then we return. And then we close the scope. That's not good because we're returning. Since we return, we never get here. So this is some cleanup. This is cleaning up this variable, but it's never happening. And this really needs to happen. That really needs to happen. So how can we get around that? Well, we can't do anything after a return. Maybe this can become like jump to dot end. And this can be end. Dot end. And we can have a return something like this. The way I'm thinking this is because we could have multiple returns, right? All the way, multiple returns within this do plus 2, within this procedure. There could be multiple returns about the place. But no matter where you return, you should basically jump to the end of the procedure, which is where we do our cleanup, and then return. That's indented too much. So how do we make it look like this? That's the question. So that's our, when we're generating a procedure. Yeah, because this is the generate procedure. So I think actually what we need to do is put a return here. We need to put a few things. Well, but how do we put, oh, I'm sorry, I'm jumping around a bit here. How do we put this in? Because this is within the scope, right? Before the cleanup. Maybe when we generate our scope, we can pass in a flag to say include end label, right? And if that's set to true, then we want to do that before this cleanup. and after this, yeah, at the end, after the statements and before the cleanup. What is this? Oh yeah, we need to revert that. We need to bring this back to this. Really? I guess we do. That's for inline, which means we also need to do it for for. But back to what we wanted to, back to the topic at hand. At the end of the scope, we need to say, you know, if we're including an end label, this is where we put it. Like that. That's where we wanted it, right? And then back in our procedure, we generate a scope and we say, yes, we want an end label. So what have we changed so far? So we've changed our scope so that it has this end label. And this, we need to change ret to this. And then we have to have ret at the end. So that's how we have ret at the end. We just put it after there. But now we need to change our return statement, which is here. So instead of this, we need to say jump to end. Just skip to end like that. What happens if I compile that? Do +2, declare, return. So that's everything normal. And this, is this what we had before? It looks kind of like it, doesn't it? So this is our return statement, which becomes skip to end. So we go to the end, we do our cleanup of our scope, and then we return. Wow. And here's somewhere we don't need to clean up, but it also looks fine. Like this is pointless, actually. We have a lot of superfluous, like unneeded assembly, I think, which could be definitely optimized out, but I think it's fine. I think that's going to work. I think that looks pretty good. So to test it, I kind of want to keep that. So make that bar. I mean, I don't think they can see each other anyway, but I kind of want to keep that. But let's, one of the reasons I put this up here, you know, when we generate our program, I put this up here. So the first thing we do is fill out our procedures. Well, I guess I needed to because they need to be seen here. But a cool side effect of that is that here we've looked through the entire program for procedures. So we can call this, let's say do +2, 3. We can call this before we've declared it because we know about them all, right? Get Xcode 0. So now when we go up to, here's our default exit. So here's our return, which puts 3 as a parameter. So it puts 3 onto the stack, calls do +2, undoes that push, assigns the return value to R8, and then does an exit call, an exit sys call with R8. I think that's perfect. So the moment of truth now, does this return 5? Okay, it assembled. Linking is generally never a problem. Does, oh, okay. 5. How cool is that? that was a bit of an advanced setup for our first test of procedures. I feel like, we've got a procedure calling another procedure. So we've already got nested procedures. Another procedure we talked about doing was POW, right? So let's have a look. Oh, I need to plug this guy in. Let's have a look. Oh, I really hope that it was recording fine when it wasn't plugged in. Getting all sorts of errors now. Fingers crossed, I don't have to do this again. So POW proc num exp. So this is the number that we want to raise to this exponent. And I did see some assembly code for this before. I think it's something like 4exp with our limited language. It'd be 4exp. Then we need to go like result 0, or is result num? I think result is num, and the result equals result times num, because we're multiplying num by itself, right? So result times num. And exp equals exp minus 1. So we keep decrementing that, and then we return result. But I'm just thinking that if we're squaring a number, then we should only go into this loop once, right? But in that case, exp is 2. So maybe we need to have this here as well. So now exp is 1, or if exp was 1, then it goes to 0. If exp was 0 or less, then we're screwed. Then we'll get a crazy, well, not an infinite loop, but it will be a very, very, very long loop. Let's just put, we can't put a comment. We don't have comments yet. But we can't handle 0 or negative numbers. It's just not going to work. But if that's a 2, then this will make it 1, which means it'll come in here, and we'll effectively get num times num. Then it'll decrement, which means this will be false, and then it'll return. But if we have to the power of 3, it'll become 2, come in here, do this, then it'll become 1, that'll pass, it'll come and do it again. So it'll be like, if this was 3, it'd be like 3 times 3 times 3. Then it'll go down to 0, this will fail and come out. I think that's good. I think that's a POW. So let's just try that. What's 3 squared? 3 3s are 9. Jeez, I got a fright there. I was like, why did nothing come out? 9. Cool. 9 times 3. If we go 3 times 3 times 3, 27. I did build that, didn't I? Now I have. $27. Awesome. We can define procedures, multiple parameters, returns. I can put a loop in there. If we look at our POW, here's our loop. We've reset the counter because anything with a dot is scoped to the previous label. So our for loop is 4.0, even though up higher we have 4.1 and we have another 4.0. Wow, that's so cool. All right, I'm really happy with this. That we can define our own procedures, and we have a useful procedure. Not just this stupid +2 +1 crap. We have a real useful procedure. Pow. This is like a procedure you would really see in a standard library of a language. Maybe they optimized it better than I have, but that's awesome. Okay. Yeah, that's it for now. Thanks for stopping by. I think what I'm really tempted to get stuck into next time is types. So let's see if we can do that. Give us a like. I do like those likes. And yeah, see you next time. Ciao for now.